This tutorial shows how to use IfcOpenShell and Python to estimate and visualize CO2 emission of building elements using material and quantity information. I will start by explaining how we define our class and walk you through some of the main methods, then show you how the tool is actually used. For this project, we have used an object-oriented approach, so we have defined a class named model with estimator, which we initialize by loading 3 IFC files representing architectural, structural, and MEP models, as you can see here. And here we validate that the model files exist. Now we will look at some of the methods we have defined for this class. This method takes a list of IFC building elements like walls, beams, columns, and the loaded models to extract information about material and quantities like length, area, and volume. Here we create an empty set for materials and quantities. Then in these two blocks, the method attempts to extract any material information for a given element and adds it to the materials set. Then in this following block, we try to extract the length, area, and volume from the element's properties and add it to the quantities variable. And finally, we wrote the results into a pandas data frame along with the element names and their subtypes. Since information about the element's material is missing in many cases, we need to assume the material and insert it into our data. This method is responsible for this step. First, we separate the rows with missing material information. Then we use the JSON file with assumed material information that we took as input and fill in missing material data by joining the file with the data frame using the subtype field. Here we join back the data that we separate above and return the new data frame. This method estimates the CO2 emissions for each element based on the material and dimensions. It takes the CO2 emission factors from a JSON file as input and annotates all elements in the data frame using the annotate with CO2 method. Then using calculate element CO2, it calculates the annual CO2 emissions for each element with this logic. If volume data is available, multiply it by the CO2 emission factor. If not, use area or length instead to perform the calculation. The results are finally added to the data frame here. Now that we have the calculated CO2 for each element, we have defined a few methods to show the results. For example, show total element CO2 displays the total CO2 emissions for each element type like IFC walls, IFC beams, and others. Or if you are interested in a particular element, you can use the show CO2 for elements method. This method takes the desired element's names and displays the CO2 emissions for only those elements. And the show total CO2 only returns a single number, which is the total annual CO2 emissions for the entire building. Finally, this method creates a pie chart and a bar chart to visualize the obtained results. We also have a generate plots method that does the same thing, but instead saves the plots as JPEG files. In the main, we create a calculate results method. In the method, we provide the path to our models and pass it to the class to build the object. Then we define the list of our desired elements and pass it to the extract element data method to extract information from the IFC files. Here we load the assumed material JSON file and pass it to the impute materials method to fill in the missing material information. Then we load the CO2 data JSON and use it to the CO2 calculations here. In this part, we call the calculate results method to get the results and use these two show and plot methods to see the results.